Anyway, so full wave center top, huh? Center top. Last time we have a full wave. What else? Last time bridge, bridge type, huh? Consisting of four diodes. But this one consists of only two diodes. But still, you can provide, or we can get a full wave rectifier output from the output side of the circuit. So how? By using what we call, that's why we call center tap. What do you mean by center tap? Center tap means this one. Because in a transformer, okay, later I will show you a transformer. Alright, this is the transformer, okay? So this is one of the transformer that we will use, okay? So, but here, you have to be extra careful because we are dealing here with AC. So actually, a center tap transformers, okay, consists of, see, you'll find here two on the side, alright, two on the side, and the other three on the other side. What's the difference between the two? This is what we call the primary. That's why I put it here. Primary side of the transformer. Alright? And the other side is what we call the secondary side of transformers. Okay? The center tap is located at the secondary part of the transformer. Okay? Now, just to be aware, I just want to be aware of the danger here. Okay? This one, in your book, you'll find that, look at your circuit in your book. There's a mistake in your book, alright? Here, in the primary, usually in the primary side of the transformer, this will have an input of either 110 or 220 volts AC. Remember, okay? 110 and 220. So it's very risky, okay? So that's why this morning, I'm always warning the student, please don't touch this one, this side. It may shock, it will give you shock. Alright, it's dangerous. Don't touch this side. Yeah, maybe if you'll be unlucky, okay? So because it's exposed, no? It is very exposed. There's no protection here. So we just put clip here, right? When you connect it. So be careful with this, huh?
So we connect the top?
Yeah, here directly. Yeah, we will directly put it here from the AC. So we'll provide 110 or 100. So you can provide 100 to 110. In your book, it's written only 5, huh? 5 volts, which is wrong. So you put there, that should be BAC. On this primary, it should be 110 volt. 100 to 110 is okay. Okay, BAC. Because that's the required. Okay, that's the required voltage from the primary, for the primary to work. Okay, that's the required voltage, 110. Some transformer 220. It depends on the, okay, but here the available one is 110. Okay, our available device here is 110, not 220. All right. Now on the other side, in your book also it's written how much? 5. So it's not 5 actually. It's not 5. Okay. So what we are dealing here is we have here the 0 and 12 volts. Also here 12 volts. So instead of 5, we will use 12 volts. Okay, output from the secondary. Okay, for the secondary side, we use 012 and 012. Center tap, because it's in the center. That's why it's called center tap. Okay, but actually, this center tap is producing 2 secondary output. And that output is the input to your loads. Okay, not like before. In your previous one, ala tool like that, diode. Then this is the loads.
Yes.
This is the input already, right? Okay, but here the input will be on this side. will be now on this side. This is the input now. Not without this. Okay? Okay? So, because this one is accepting AC and AC signal, and this one also is delivering AC also. AC signal like this. AC signal. Okay? But from high to what? Low voltage. That's why, because we have, also we have, in transformer, we have two kinds. Step down, we call it step down and step up. When we mean step down, from high to low, going down, stepping down, step downs, that's why it's called step down. From big voltage to, or down to low voltage, step down. Okay? Some transformer also, there is low and then become high. Okay? From low to high, step up, stepping to up, or step up. Okay? So what we are using here is step down. From 110 to 12 volts. Okay? To 12 volts. Alright. So as you can see here, this is your 12 volts. Alright? This is your 12 volts input. So we have two. So I put it here. I call it S1 and S2. Secondary 1, secondary 2. Or we call it half of it or something. Okay? As we like, as we like. Alright? So now, same thing will happen. Look, let's analyze it. How will you now produce a full wave signal using a center tap transformer? Using only what? 2 diodes, right? Before we are using 4. Now we use 2 diodes only. And we can still produce full wave, but the difference is here we have to use the center tap transformer. Alright? So now, the blue color represents, okay? The blue color represents the first cycle or the positive cycles, because there are 2 cycles, positive and the negative half, right? 1 half and 1 half, correct? So during the positive half cycle, what do you think will happen? Again, like the previous discussion we have, during the half cycles, there should be a diode who will switch on, or will become forward bias. Always this is the case, right? That's always the case. Alright? So in this case, where do you think, which diode will be forward bias? D1 or D2?
D1.
So yes, obviously, right? Why? Because plus, what is this? Plus, which is the anode side, right? The anode material. So the plus here, or the diode D1 will allow the plus to go through,
Yes.
alright? Go through there, going to the load, resistor. And since your center tap is what we call a common terminal, it can either be minus or plus. Okay, but during the positive cycle, the center tap is in the minus side, right? Minus side, plus, go there, minus, with here, so meaning, signal, permitted, go through, correct? So meaning, permitted, right? But this one, mafi, because negative, off, on, or forward bias, but this one is off. During cycle, per cycle, first half cycle. Alright? And during the negative cycle, negative half cycle, so again here, D1 forward bias. And this one, obviously what? This one, what? D2 forward bias. Why? Look. During the negative half cycle, minus off. Trap, right? Trap. Cannot go inside, right? But this one, where? Plus now here, it will allow, the load. It will allow the current to flow to the load, RL. And since this one now is also negative, so there will be the output. So it will allow the signal to go. Right? So both of the signal are permitted to go to the output during the positive half cycle and the negative half cycle. Okay? This is for D1. Sorry. This is from D1 and this is from D2. Correct? Clear? Alright? Now, so expected that again there will be a full wave signal on the output. And be aware of again, last time, okay, remember last time we have an issue with the oscilloscope. Okay, so only use one channel, right, in measuring the input and the output. We cannot do it in the same time. Some issue on the oscilloscope. And another thing, these are new sets of formula that you will use because this is different. I saw it's different compared to the previous tables. Okay, here in this lab we have 3 additional formula. We know this formula already. This is B and RMS. We are using it before, right? We used it before in the previous lab 1, 2, 3. Okay, but these 3 are new. For lab number 4, we are having 3 additional formula. One formula is the percentage error. So just apply the formula B in. Where is B in? This one. This is the B in the RMS value. You get from here. Okay. B and AC. This is by using what? B and AC. DMM or oscilloscope? B and AC. Let me see. BNAC. Yeah, so this one can be determined using DMM, by DMM multimeter. Alright, so this one from this, alright, but to get this you have to get this, and this one is being done by the where should you get this value? Where can you get this value? The V in peak-to-peak values. Where will you get it? DMM or the oscilloscope? Oscilloscope, sa?
Yes.
Peak-to-peak value, V in. Where is it? Here, sa?
Yes.
V in peak-to-peak. Again, remember, that's B in peak-to-peak. Alright? This is B peak-to-peak value. That point. Peak-to-peak value. Sa? So this will come from the oscilloscope. Okay? So you have this one from oscilloscope. You have this one from DMM. Same thing with this one. Multiply by 100, give you the error. Clear?
Yes.
Question. Is it clear or not? Clear? Okay? Next. Yes. Yes. V out RMS. V out peak. So meaning V out peak where? The output peak. Half of the waveform. Not the whole. Okay? Half of it. Okay? This is the half cycle. Okay? So V out peak square root of 2 will give you V out RMS. Same thing here. V out peak, same value here. Will give you B out DC, but different formula only. 2 multiplied by over pi. Alright, this will give you DC, this will give the RMS value. I think this is also called average value, this one. The average. Alright? Clear? Just follow the rule. Okay? You know how to measure by DMM. I already teach you how to measure the waveform. It's easy for you. So, wala. It will be easy for you, right? Because you know how to do it already. Just follow the table, see each of the column which is required, then do it. Okay? Step by step. Alright? Class? Question? No. No question? Clear? Okay, let's start the